Okay, welcome to another video of this concatenated synth. Oh, sorry, I was facing the wrong way. What I was trying to say was welcome to another video of the concatenative synthesizer. I've now made a version tagged 0.5.0, and these are the additions to this version. So it doesn't look like a huge amount, I think, but each one kind of took quite a while, and I encountered many problems along the way, and I had to just sort of think about how to do certain things. So probably the biggest changes are this audio segmentation and the feature weights that I've added. So I was looking back at the original paper that this was based on, and I realised, well, not realised, I deliberately couldn't be bothered to do it before, but now I have done it. When it's doing the analysis of the source sounds, like detecting the pitch and the spectral energy and that kind of thing, what it does as part of that is actually segments the audio. So what it means is when you give it a single sample, it will segment that audio, or split it up via different means. So before I wasn't doing that. What I was doing was just saying for every sample, say I gave it 100 samples, I would say just take 0.1 seconds of this sample and do that for each of them. So it meant that if I was providing 10 sounds, I would just get 10 samples out of it to make up the body of the database. But now, by using the segmentation and saying, okay, split it into chunks of 0.1 seconds each, and then give me 10 samples out or something like that for each one, or split it on rhythmic events or like onsets that are detected in the sound. So I'll show you a bit how that works. I have this script here, and it's splitting up a drum break, and the segmentation is set to none at the moment. So if I just run this, you can see that for this drum break it basically just took that amount of the sound. It just took 0.2 seconds worth of the sound and then throws the rest of it away. What I've done now is added these different segmentation strategies, and there are 3 of them. There's slices, onsets, or none. None is just as it was before. So if I do slices and I run it now, see, it's split up into equal length slices. I didn't really know how to represent this other than like alternating colours, but so rather than just getting one bit of the sound, we get all of the sound now. And the way that's controlled is in one of these config files. So as we're running it in a script, I have to change it in the code directly. So it's saying that for an onset, the maximum segment length, for a slice, the maximum segment duration is 0.2. So if I change it to like 0.8 and rerun that, then as you can see we get bigger slices and fewer of them. The other one is onsets, and this uses a function from Librosa to detect the events in the sound. But with this one, as you'll see, I'm not really sure how well it's working, because I mean we get different size ones, which is nice now because it's going from one onset to the next one. But I mean it doesn't really always capture the onset where you'd expect. Maybe I would have expected it to capture it here or something, but it captures it there, it captures little bits there, but other ones. So I'm not entirely sure how well this onset one is working, but what this means is that we can get many more samples out of fewer input sounds. But a downside of this is that the size of the database grows massively. So suddenly, where I was providing 200 sounds before and getting 200 little slices out, sometimes now I get like thousands of bits of audio out. I think I have a screenshot that I took somewhere in these notes I've been keeping, which showed a very dense. Yeah, here we go. So you start getting stuff like here I got 3,000 snippets, so you just get this really heavy, dense cluster of sounds, and that was when I zoomed in on a little bit of it. So it does get a bit intense at times if you do that. And let's just see what it sounds like. So if I run something, so I'm using these sounds. I downloaded sounds from the video game Max Payne, and it turns out it's just sounds of him talking, basically, or over dialogue of the film, the game. So
I had become a cold-blooded murderer. I had screwed it up.
And then you have other sounds in there, like I think you these kind of sounds.
The stress was getting to me. I'd made a mistake I'd never be able to fix.
So if I run the code again on those sounds, so what I'm doing here is I'm providing the Max Payne directory, 30 seconds of output, slice length of 0.3, max sample slices is 5. Now that's to prevent it from growing too large. So if I don't provide that, if I take away that command, we'll see how many we get. And then I'm just doing it on the RMS, which is basically going to give me the it's going to make all its calculations for which sound to go to based on the volume of each sound. So if we run that, so I got 134, and then okay, so it gave me 4,856. Luckily, RMS is very quick to calculate, but basically it split all of the sounds into. It split, I think, 100 sounds. Maybe it says it up here somewhere. It's gone from the log. It's about 100 sounds, and it split it into 4,800 sounds. So it's quite a lot. If we listen to that, what does it sound like? So in this particular case, it's mostly picked very quiet sounds, and then at some point there's a very abrupt jump to a loud sound 25 seconds in, so we should hear that in a second. I don't know why that's happening, by the way. So okay, you know, sometimes I wonder what the hell am I doing. And okay, so that actually brings us on to another point. As you can see here in this command line, I actually passed in this config file. So that allows us to configure things, because the command line is getting a bit unwieldy. So if I say synth help, there's quite a lot of parameters, and even though I made this, every time I look at it I have to remind myself of the help. So some other features that you can tweak, or parameters you can tweak, I've started putting into these config files, and maybe a lot more of it would move into that at some point. So if I just go here, there's not that much in it yet. I've got to add a fair bit more, but this is basically a way to control some extra parameters without polluting the command line too much. So if we go back to what I was doing, segmentation slices, so it was segmenting it into slices of 0.1 seconds. If I make it a bit bigger, 0.3, and also if I change the max slices again to be 5, so we'll have a smaller corpus of sounds. Let's see how that goes. So now we get 660. RMS is very quick to calculate, as you can see. This one looks like this. So this one is very different to the last plot we saw. It isn't just using very quiet sounds. It is actually growing in volume very gradually. You might not even really be able to hear it here, because all of these sounds come from the same source, and they're mostly dialogue. They're all kind of at a similar level. Maybe we'll just listen to it. see what it sounds like.
A monitor, there's standards, tables, and punch a potatoes term of the just left after all the grips on the tape. Off it, I'd be all self-drying for cat project taping. The price switch of price when the piece ratio land been took out. I was in sub which maybe else control for being full good after on me cusp by the bottom on the place works these dead to me. Horn after fingerprints have been winning exit V Mark guy going get to the fuck you. Some way full score caught me get to the fuckers and the under go me caught me all lap me up for the
That's enough of that. So I don't know if it's really clear there that the volume is increasing over time. What is maybe a bit easier if I use whatever the last files I downloaded from YouTube were, if I use them instead, I think it's a bit more clear there, because those sounds, they're completely random, so there's no equalization in the levels and stuff like that, so there's a lot more variety in the volume. So if I use some of them, and I'll reduce this to 2 just so we don't have too many sounds. So now it's loading 257 and it's going to give us 500 snippets, and the plot for this one looks like that. So okay, it's maybe not as much as I thought actually. I'll listen to it anyway.
When money I do. That's me. Pretty.
Sometimes I'll try and generate one more. Sometimes you get very clear examples of when it's like decreasing and then increasing. Let's have a look at what this one looks like. Yeah, I mean, again, the amount of change in the RMS is not huge, really. Let's give it a bit of a listen anyway.
That's 100.
Very quiet now.
This now.
A bit slightly louder at some point.
We can
Very subtle.
this
I have them.
goal to do.
If I stop just plotting RMS, you tend to get more interesting results if you use all the default features, which is RMS, spectral centroid, and pitch. So if I do that, it takes a bit longer to generate now, because I think particularly like the pitch and the spectral centroid, particularly the pitch, takes a while. I think it's not that long, but it's noticeably longer. And when we do all of those features, then we can start plotting this map again, where it's the 3 sounds on the like 3D plot of the sounds, and again showing you the path that it's taken. So I play the sound. So it's getting quieter. It's getting quieter.
Bankrupt.
Yeah.
So the spectral centroid and the RMS have kind of similar-ish plots. You see it goes sort of up and then down and then follows around like that. There's a kind of overall structure you can see in it, whereas the pitch is is much more random, I would say. What I've added, another thing I added is, sorry, if I go to the changelog, is feature weights. This is another thing that was in this original paper here. So when it calculates the nearest neighbours to use using some sort of distance function, there's also a weighting that is applied. So you per feature. So if you wanted, say, the pitch to dominate in the calculation of the nearest neighbours and which samples to move between, then you'd give the pitch a much higher weighting than the other two. So I can try that now as well. There's again another command line parameter for it. So it's weight. So it's list of the feature weights per feature. So at the moment we've got RMS, pitch, and spectral centroid. So if I wanted pitch to dominate, I could try doing features and then weights, and giving 0.1, 0.9, say, and 0.1. This should, in theory, weight. Maybe it should be weights. This should, in theory, make the pitch the predominant feature that it bases its decisions on. But the pitch one, it is kind of, it's much less predictable, especially when you get these sort of random sounds from YouTube. Oh dear, oh dear. Well, we'll just pretend that didn't happen and hope it doesn't happen again. Alright, well, okay, so it came through. Let's see if there's any more consistency in the pitch. Yeah, so there actually, yeah, the pitch has a clearer trend, right? I mean, the RMS and the spectral centroid, there is still some overall trend, but it looks like it is actually following a more consistent shape with the pitch rather than like a contour, rather than it just being all over the place. So we'll listen to that one.
Hey, 5 bottom.
You plug your temper. Clearly.
Form.
It's getting louder as well.
This
Well, anyway, it's kind of hard to tell with the pitch, because the pitch one, especially the pitch one, is weird because it's using a whole snippet of sound, like 0.2 seconds or however much it is, and saying this is the pitch of that sound. Whereas, I mean, there could be multiple pitches in it. The pitch could vary across the sound. So just to come back with one single value is a bit unrealistic, I would say. I don't know how meaningful that is. Anyway, this video is getting on quite a bit now, so I will bring it to an end. But once again, it's just an overview of these features that are going into this synthesizer. Showing you the list of what I have to do for the next one. One of the big ones is adding a target source. Because like I said, at the moment I'm just doing it sort of free form and letting it generate itself, but really what people normally do in this kind of work is have a target that it's trying to mimic or resemble as close as possible. So that'll probably be something I try out next. Anyway, thank you.